Okay, this lesson is on finding binomial probability using a graphing calculator. So if you have a binomial probability scenario where you have repeated trials happening, for example in basketball taking 10 shots, you have independent probabilities. So you have, let's say, a probability of success of making your shot at being 70%, and you only have two outcomes, either making it or not making it. So I'm taking 10 shots, probability of success being 70%, and there's only two outcomes, either making it or not making it. I want to calculate in this case the probability of making exactly 6 shots. So on your graphing calculator, above the vars button, you have a distribution, and the distribution is what I'm looking for here. So I'm going to go second and then the distribution button, and then I'm going to scroll down until I see Binomial PDF. Binomial PDF, which is option A. I hit enter. Now it's Binomial PDF because it's one individual outcome looking for, the probability of making 6 shots. So here in this example I had 10 trials. I had a probability of success of being 0.7 for 70%. And then my X value I was trying to calculate was 6. Now this is on a TI-84 plus CE. So I'm going to then go down to hit for paste, hit enter, and it tells me what to put in. I hit enter again, it gives me my answer of being about 20%, okay, or 0.2. Now if it was on Texas Instrument TI-83 plus or the TI-84 just regular plus or silver editions, most things would be the same. I'd go second, then distribution. I'd scroll down till you got to Binomial PDF. I would hit enter. Now this time I'd have to put the numbers in exactly. I would have to know the order to put in. And it goes NPR. So it'd be 10. And then I do comma. The comma button in between. 10, comma. Then my P was 0.7, so I go 0.7. Then I'll hit comma again, and then my R would be 6. Close bracket, hit enter, and you get your answer. Now if it was, for example, new scenario, the probability of me making less than 6 shots. So here I have a cumulative probability where I have a probability of making 0, 1, 2, 3, 4, 5, and 6. There's lots of different scenarios. Probability of making 6 shots or less. Okay, so I do the same thing. I would go second distribution. You would scroll down, and this time, because it's cumulative, it'd be Binomial CDF, which is the one right below. You hit enter, and I put in the same things, my N, my P, my R. Okay, so I go 10, comma, 0.7, comma, 6. Now this 6 was the less than or equal to value that I was putting in, because it was cumulative. It was all those probabilities leading up to and equal to 6. Close bracket, hit enter, and you get your answer. This time is 35% because it's cumulative, all those probabilities leading up to it. If it was probability of making at least 6 shots, now I'd have a little bit of change. At least 6 shots, the cumulative probability, the binomial CDF, gives me less than. Well, in this shot in this question I want greater than, so I have to do 1 minus, and instead of I want greater than 6, greater than equal to 6, which means I'd be less than 5. I'd be taking away from 100%. The binomial CDF does not give me greater than, it gives me less than, so I have to take it away from 100%. So same steps. Second distribution, go down to Binomial CDF, hit enter, and I'm going to put in my values, which was my 10 trials. My probability of success was still 0.7, so 0.7, commas in between, and this time I want to put in 5 because I want greater than equal to 6, which means I'm taking away, I want to find the value of less than equal to 5, which was 15%, so I'm going to go 1 minus 1 minus that 15%, which is going to give me 85%. So the binom CDF gives me the less than. If I want greater than, I have to take it away from 100%. Okay, short little lesson on using graphing calculators, either TI-84 or TI-83, and how to find binomial probability. Thank you very much.